In this video, we'll look at the infinite series, the sum from n equals 2 to infinity of ln of n quantity squared all over n cubed. We'll see if this converges or diverges. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, so the first thing we're going to see is that ln of n is less than n to the a for a bigger than 0, and of course as n goes to infinity. So you can see that, or we're just going to show that. Okay, so we're going to look at the limit as n goes to infinity of ln of n all over n to the a. Okay, so the top will go to infinity because ln of infinity goes to infinity, and n to the a. So it would be infinity to some positive value because a is positive. So this will also go to infinity. But we can't use this. This will just be L'Hopital's rule. So that says this will equal the limit. So the fraction will stay the same. We're going to do the top derivative over the bottom derivative. So take the derivative of the top function, which is in terms of n. So this will be 1 over n all over the derivative of n to the a is a n to the a minus 1, just the power rule for derivatives. Okay, multiply top and bottom by n because that doesn't change anything because that's multiplying by 1. 1 over n times n will cancel. So this will just be 1 over a can bring to the outside because it's a constant. So this will be the limit as n goes to infinity of 1 over n to the a, where a is bigger than 0. Again, so this means it's 1 over infinity. So it's 1 over a times 1 over infinity, which goes to 0 because the bottom fraction, the denominator is so big, so 1 over that will be 0. So this shows that ln of n is less than n to the a for n bigger than, going to infinity for a bigger than 0. Okay, so that we checked that. Okay, so let's plug this in. We'll just say the original sum from n equals 2 to infinity of ln of n quantity squared all over n cubed. So now we know that's less than the sum from n equals 2 to infinity. We can replace both ln of n's with n to the a. So that would be n to the a squared. So let's just write it as n to the a squared all over n cubed. Okay, so this will be the sum from n equals 2 to infinity. So this will be n to the 2a all over n cubed. But we can move the n to the 2a to the bottoms by subtracting by it, so it would be like this. And then this will just be left with 1. Okay, so we know that the sum from n equals 2 to infinity, or any values for that matter, of 1 over n to the p converges when p is bigger than 1. That's the p-series test. So p equals 2 works, any number bigger than 1 works. So that means we must have that 3 minus 2 alpha, or a, is bigger than 1. Because if it's equal to 1, it will be the harmonic series, because 1 over n diverges. The sum of 1 over n diverges. Okay, so this will be minus 2a bigger than 1 minus 3 is negative 2. So a is less than, because the negative sign will change it to be 1. So a is less than 1, but a is bigger than 0 in the beginning. Okay. So we can pick any values between 0 and 1. So let's just pick a to be 1/2. Okay. So that means that ln of n is less than n to the 1/2, which is the square root of n. Okay, so the sum from n equals 2 to infinity of ln of n squared all over n cubed is less than the sum from n equals 2 to infinity. And we can replace this square root of ln of n squared with square root of n quantity squared, which is n, all over n cubed, which is the sum from n equals 2 to infinity of 1 over n squared. And now this 2, what does this represent? P equals 2, which is bigger than 1. So this means this converges, and that is the end of the video. Hope you liked it, and thank you for watching.